Chapter 10, still dealing with inequalities and absolute values. So this is a very interesting section. So I really want to go over some things, and I want us to understand how inequalities are affected when we talk about absolute values. We saw compound inequalities earlier in 10.4, and now we're doing inequalities with absolute values. So we're going to do equalities first. Let's take this statement. Let's take this situation. X is equal to, or the absolute value of X is equal to 3. So we have to think about what value in here could we possibly have. So think about, well, the most natural number that we could think about is 3, right? If we have the absolute value of 3, that equals 3. Yeah, absolute value of 3 is 3, so that works. So that is definitely one of the solutions. What if we had negative 3 for x? What if x equals negative 3? So we'd have the absolute value of negative 3 equals 3. So the absolute value of negative 3 would be 3, and it again makes a true statement. So these are my two solutions. If I graph them, I would have negative 3, 0, 3, and I'd have 2 dots because there are only two solutions. No other number, if we plugged in 0, absolute value of 0 does not equal 3. If I did negative 6, the absolute value of negative 6 is 6. 6 doesn't equal 3. So there's only two solutions here. All right, now, so that's with an equal sign. And if we had an inequality, what if we had the absolute value of x is less than or equal to 3? Okay, so let's think about values that work here. So if we plug in 0, is 0 less than 3? Yeah, 0 works. So let's do it on a number line. Let's do 0, let's do 3. So 0 works, that's a solution. Let's try 1. Does 1 is absolute value of 1? 1 is less than 3. Okay, so 1 works. 2, yeah, 2 works. 3, does 3 work? Does 3, yeah, 3. Okay, does 4? 4, what if we do 4? Absolute value of 4, is 4 less than? No, so 4 does not work. So 4 is my first not true. So this is not true. 5 doesn't work. So all of these are going to be false. So 4 is wrong. 5 doesn't work. Okay, so we did past here. Let's go back in this left direction. So let's try negative 1. So negative 1, absolute value of negative 1 is 1. Okay, so negative 1 works. Negative 2, absolute value negative 2 is 2. 2 is less. So 2 works. Negative 3, does negative 3 work? So I'm sorry, we should be writing solutions. 3 works, right? Negative 1, negative 2, negative 3 works. Negative 3, absolute value negative 3 is 3. Is 3 less? Yes. How about negative 4? Absolute value of negative 4 is 4. 4 is not less than, so negative 4 doesn't work. Negative 5 doesn't work, so nothing outside of here works. So the solutions are actually all between here and all the decimals and fractions. So we do a closed circle, and if I had to write that, since it's an intersection, guess what I would use? I would use an and. I would write negative 3 is less than or equal to x and less than or equal to 3. That's a compound inequality, and that would be an and sign. So this gives you a little hint into absolute values with less than. Less than signs are going to be an and. We're going to create two statements here. We're going to separate them, and then we're going to create an and statement. So the real way to do this, if you start with this equation, you write x is less than or equal to 3 and x is greater than or equal to negative 3. We flip the inequality sign and we make it negative, or we make it negative. And so this is that statement. It's kind of cool. So that's when you have a less than sign. What if you had the absolute value of x is greater than or equal to 3. How does that affect our solutions? So we'll again do 0. We'll look at 3. So let's start plugging in values. So if we plug in 0, is 0 the absolute value of 0 greater than 3? No. 0 doesn't work. What if I put 1? No, 1 doesn't work. 2? Nope. 3, yes, that's my first solution. Absolute value of 3 is 3, and 3 is greater than or equal to 3. That's equal to it. How about 4? 4 works. 5, 6, 4, 5, 6, all the way to positive infinity. So these are false. Okay, well, let's go to the negative. What if I try negative 1? What if I put negative 1 in here? Absolute value of negative 1 is 1. Is 1 greater? No, so negative 1 didn't work. Negative 2? No, that doesn't work. Negative 3, what about negative 3? If I put negative 3, absolute value negative 3 is 3. All right, negative 3 worked. Negative 4 worked, so let's write negative 3. That worked. Negative 4, negative 5, negative 6. All of those worked, and in fact, all the way to negative positive infinity. Now we have wings, and hey, greater than. So if we had to write this, if we had to write it as a solution, that solution would look like x is less than or equal to negative 3, or x can be greater than or equal to 3. So we notice that those produce an or statement. We have wings here. So any greater than is going to be associated with or, with absolute values. And we would, again, the way we would write it is you'd write this statement, but then because it's greater than, we write or. X is, we flip the inequality sign and make it negative. So is that the same statement? Yes, it is. So that's how we are going to do absolute values. And it's important for us to understand that and why these are true and why we apply these situations. So this is an equal. So we're still going to write two equations. We're going to write m minus 3 equals 5, or m minus 3 can equal negative 5. Because remember, inside here can be equal to 5, or inside here can be equal to negative 5. That's the beauty of that thinking. If we understand what absolute values represent, this comes out to be relatively simple in concept. But you do have to think about it and, understand what absolute value and what can be in here. This can equal either 5 or negative 5. If it equals negative 5, what value for m? If negative 2, that becomes negative 5, and then we take the absolute value, which would be a solution. So if we're going to this is just solve. We don't have to graph. So, but if we had to graph it, we'd just do negative 2, 0, 8, and we do dots. So when we have solutions, we just make a dot there. So that'll be the last one. I don't know why I did graphing. We're going to write two statements. We're going to write k plus 4 can equal 1, or k plus 4 can equal negative 1. So let's minus 4. K can equal negative 3 minus 4, and k can equal negative 5. So actually the way that we write this is more in a solution set, and this is the better solution. So we're not going to graph. We'll take that away. We'll take all these away, delete. Doesn't say graph, but, and then we write it in numerical order. So those are the two solutions, negative 5 or negative 3, and negative 3. I don't know if there's really an or an and in this. We have two solutions, and I guess. So if we plug in negative 5, we get negative 1, absolute value of negative 1 equals 1. If we put in negative 3, we get 1, absolute value of 1 is 1. That's why all this is, oops. Delete these. So we're going to write two statements. 2 plus x equals 4, and 2 plus x equals negative 4. We're going to minus 2. X equals 2. We're going to minus 2. and x equals negative 6. The solutions are negative 6 and 2. Easy as that. 7 minus x equals 3. 7 minus x equals negative 3. Well, minus 7, negative x is equal to negative 5. Multiply both sides by negative 1. X equals positive 5. Minus 7, we get negative x equals negative 10. We can divide by negative 1 also. That's a nice inverse. And we get x equals 10. So our solutions are 5 and 10. If we plug them in, 7 minus 5, 7. 4. Hello. 3 minus 7. Wow. I totally just... Thank goodness I checked. Kids, here is your first reason why you check. 7 minus 4 is 3. 7 minus 10 is negative 3. Absolute value of negative 3 is 3. But great reason why we check our solutions. Sometimes we make mistakes. X minus 5 equals 2. X minus 5 equals negative 2. Add 5. X equals 7. Add 5. X equals 3. My solution is 3, 7. 3 minus 5 is negative 2. Absolute value is 2. 7 minus 5 is 2. Absolute value is 2. I keep doing that. Sorry. My mistake on putting these silly number lines out there, thinking that we were going to graph. Negative 7. We'll solve for x. We get 1. Multiply both sides by negative 1. X equals negative 1. Minus 6 minus 6. Negative x equals negative 13. Multiply by negative 1. X equals positive 13. My solutions, numerical order. We're not putting them in coordinates. We are not using parentheses. We're using solution sets. I see that quite often. People think that parentheses are solution sets. No, parentheses show points, and that's a coordinate. That's an x and y value. Those are two different values. This is for the same variable. A coordinate has two different variables. Negative 1, that negative, the opposite of negative 1 makes positive 7. 6 minus 13 is negative 7. Absolute value is positive 7. All right, now we have our inequalities. So we are going to and graph its solution. So we're going to write two statements. We're going to isolate. First of all, remember to isolate. I don't know if this is going to be the case in this one, but isolate the absolute values first. They're isolated. There's nothing multiplying, adding, or subtracting. So we will get x is greater than 2. This is a greater than sign. So greater than means or. Less than means and. Very important. So this is going to be an or. X is greater than 2 or x is less than negative 2. So let's graph those. And we're again back to sketching. We have to sketch our solutions, and then we will write our answers on our solution graph. So let's graph this. This is negative 2, 0, 2. Let's use green. X is greater than 2. Open circle, go in that way. X is less than or equal to 2, or less than negative 2, goes that way. Since it's an or, I only need one, or at least one. So we can write this solution is going to be negative 2, 0, 2, open circle, and that would be my, that would be my graph. That's way out there. That would be my graph for my solutions. I don't think I have to write a sentence, solve each open sentence, graph its solutions, but I'm just going to do it to stay consistent. X, is it X? X is less than -2 or X is greater than 2 would be the number sentence for that. Okay, let's bang that down a little bit. What? Is that the same problem? No, different problem. Oh, it's less than, that's why. So we have X is less than or equal to 2 and X is greater than or equal to -2. So do that in green, that in blue. Let's sketch. -2, 0, 2. X is less than or equal to 2, closed circle going there. X is greater than or equal to 2, closed circle, greater than. So the intersection is going to be closed circle, closed circle. So if I pick a number outside of this, like -4, the absolute value of -4 is 4. Is 4 less than? No, that was false. How about over here? Let's do 3. Absolute value of 3 is 3 less than? No. Let's go inside here. Let's try 0. 0 less than 2? Yes. How about -1? 1 is, yep, -1 pops out 1. 1 is less than 2. Nice. So you see why this is the solution to the absolute value inequality. And then if we had to write it, we'd write -2 is less than or equal to x, which is less than or equal to 2. Nice way of doing that. Good knowledge. Hopefully you're getting this and you understand why these particular constraints are placed on it. So this is greater than, so we have x is greater than or equal to 1, or x is less than or equal to -1. Green, blue, sketch it. So we have -1, we have 0, and we have 1. Green is x is greater than or equal to 1, x is less than or equal to 1. Whoops, sorry, that should have been in blue. Almost sounds like I hear a turkey gobbling. Maybe it's a dog. It's an or, so can you hear that? I don't think you can hear it. Maybe it's a dog. It's probably a dog. That is the problem with doing these at home. You get some interesting noises. This is the solution. And then if we had to write it, it's an or, so x is less than or equal to -1, or x is greater than or equal to 1. Yep, that's a dog. It does sound like a turkey, though. It sounds like it's gobbling. X minus 2 is less than 1. This is a less than, so it's an and. X minus 2 is greater than -1. Remember, we flip the inequality sign and we make it negative. So add 2, x is less than 3, and add 2, x is greater than 1. So let's graph it. Let's sketch. Let's move that solution sketch down. We'll do this. We have 0, 1, and 3. Green, x is less than 3. That's an open circle. We have x is greater than 1. That's an open circle. That's an open circle. And now, where do they intersect? Where do they overlap? Because and is true, true. So that's going to look like this. We have 0, 1, and 3, open circle, open circle. So open circle between that would be my answer. And then you have 1 is less than x, which is less than 3. So practicing that is really going to pay off. If it doesn't pay off in 8th grade or Algebra 1, then it'll pay off in Algebra 2 when you see inequalities and absolute values, because you will see it and you'll be ready for it. So even though it's not being asked, x minus 2 is greater than 2, that's greater than, so it's an or, x minus 2 is less than negative 2. Let's solve. X is greater than 4. Let's solve. X is less than 0, and it's an or. So, and if you need markers and you need to graph, by all means, always get a nice sketch pad when you're graphing and draw out. Don't feel like you have to write it in this small space. So we're going to graph this. X is greater than 4, so that's an open circle. And then x is less than 0, that's an open circle. And or, so it's going to be a union of the two solutions. So that union looks like this. And this is the solution. And then we write x is less than 0 or x is greater than 4. Keep going. X plus 2 is greater than or equal to 1, or x plus 2 is less than or equal to negative 1. Minus 2, minus 2. X is greater than or equal to negative 1. Minus 2, minus 2. X is less than or equal to negative 3. We get the or, and we get that. Let's do a sketch graph. That would be negative 3, negative 1, 0. This is good for understanding number lines and how numbers are represented. Let's do a less than, green. Let's do blue. So x is greater than or equal to negative 1 looks like this. X is less than or equal to negative 3 looks like that. That's pretty good. And now it's an or, so let's graph on our final. So that's 0, that's negative 1, that's negative 3, closed circle going that way, closed circle going that way is our solution. And we get x is less than or equal to negative 3, or x is greater than or equal to negative 1. Good. Let's do x minus 1 is less than or equal to 1, less than, so that's an and. X minus 1 is greater than or equal to negative 1. So let's add 1, add 1. X is less than or equal to 2. Add 1, add 1. X is greater than or equal to 0. And that's an and. Let's move this down so we can have our sketch. It's our sketch. Let's do colors. Sorry, I got to put those. Let's do 0 and 2. And let's do that. Let's do this. Let's do green is going to be x is less than or equal to. So green is less than or equal to, closed circle. X is greater than or equal to, closed circle. And where do they intersect? So they intersect. Let's do 0, 2. That's a bad 0. Looks like a weird 6. 0. It's going to be closed circle going here and closed circle. That's going to be my solution, my graph of my solutions. And if I had to write a sentence, I'm going to write 0 is less than or equal to x, which is less than or equal to 2. Yep, I'm doing a video. Ow! I am doing a video. I'm almost done. I know you need help. I'm sorry.
Where's your car? Where's your car?
My car was stolen. No.
Yeah, no.
Campbell has it. Bye. Oh yeah, welcome to the McCausland household. Let's write two statements. X minus 1 is greater than or equal to 1. That's greater than, so it's going to be an or. X minus 1 is less than or equal to negative 1. The other children are home. The other children are home. Oh, maybe not. Well, they're pretending. Plus 1, plus 1. Oh yeah, what a good video. Welcome to the life of a teacher on a Saturday, April 24th at 5 p.m. Less than or equal to 0. Let's move this. Let's do this. Let's do our sketch. We have 0, 2. Let's highlight. We have this. We have this. We have green. X is greater than or equal to 2. That's going to be a closed circle going like that. X is less than or equal to 0. Closed circle going like that. It's an or, so the wings are okay. We don't mind wings when it's an or. And it'll be closed circles, closed circles. That is my graph of my solutions. We get X is less than or equal to 0, or X is greater than or equal to 2. How many more do I got? Oh, I got way too many. Not going to be able to help you, honey. Sorry. X plus 3, less than or equal to 1. That's less than, so it's an and. X plus 3 is greater than or equal to negative 1. Let's solve them. Isolate the variable, negative 2. Isolate the variable using the inverse operation, negative 4. Let's move this silly graph down a little bit. Let's write this graph, my sketch graph, negative 4, negative 2, 0, numerical order. Let's say that that'll be in green, that'll be in blue. Let's look at those graphs. X is less than or equal to negative 2, closed circle, going that way. X is greater than or equal to negative 4, closed circle, going that way. It's an and, so we're looking for the intersection. And we'll get negative 4, negative 2, 0, closed circle between negative 4 and 2. Hopefully you're getting this and you're understanding it super easy and you're becoming very proficient at it. And even at writing the statements at the end there. Let's see, X is plus 1 is greater than 1, greater than is or. X plus 1 is less than negative 1. So we're going to minus 1. X is greater than 0, minus 1. X is less than negative 2. It's an or statement. Do my sketch for my solutions. I'm going to write each of the compound down, and then I'm going to look and see at the statement. I'm going to look and compare and be able to write one statement representing both the whole entire solution. X is greater than 0. Open circle. X is less than negative 2. Open circle. Intersection, or a union, excuse me, it's not an intersection, it's a union, or is union of the two solutions. So we're just putting them together. X is less than negative 2, or X is greater than 0. No equal signs, so they're open circles. All right, hopefully this is getting easier and easier. X minus 3 is greater than or equal to 4, or X minus 3 is less than or equal to negative 4. Add 3. X is greater than or equal to 7. Add 3. X is less than or equal to negative 1. Negative 1, 0, 7. Colors. That was a song back in the day. So X is greater than or equal to 7, closed circle, going to the right. x is less than or equal to negative 1, closed circle going to the left. Negative 1, 0, 7, closed circle, closed circle. We get x is less than or equal to negative 1, or x is greater than or equal to 7. Solution set. X minus 4 is less than 2. Less than is an and. X minus 4 is greater than negative 2. Add 4. X is less than 6. Add 4. X is greater than 2. That's an and. Sketching. We get 0, 2, and 6. I want this in green. I want that in blue. Write that in green. X is less than 6. Open circle. I want this in blue. Open circle. Greater than. And the intersection, because it's an and, it's going to look like 0, 2, 6. Open circle. Open circle. Yep, that's where they overlap. That's where they intersect. 3 minus v is greater than or equal to 5. Greater than. It is greater than. And I keep saying we haven't needed to isolate it. So everything has always been isolated, meaning everything outside has been moved over. We've isolated. We've gotten the absolute value. We look at it as one whole thing. It's isolated. This is greater than, so it's an or. 3 minus v is less than or equal to negative 5. So I'm going to minus 3. We get negative v is greater than or equal to 2. Divide by negative 1. We get v is less than or equal to negative 2. We had to flip it again because we divided both sides. Minus 3, negative v is less than or equal to negative 8. We're going to divide by negative 1. We get v is greater than or equal to 8. So, let's move this because we got to do our sketch solution. Move you down there. Let's do our sketch. Negative 2. That's a horrible negative 2. Let's take our time. Negative 2, 0, 8. We'll do this statement in green, this statement in blue. Green says v is less than or equal to negative 2. So that's a closed circle going to the left. This one says v is greater than or equal to 8. We'll go that way. It is an or statement. So we only need one true. It can be one or the other. So that is going to be our solution. So if we're going to graph that on one graph with no colors, no assumption, we are just going to write it as if there was a solution. Some problems we have to write the intersection and we can't have overlapping stuff. So that's why we're doing this. Did I not write the solution to the last one? Did I? Oh, I did not. That was bad. That is the solution. And that solution is 2 is less than x, which is less than 6. Sorry about that. I was saying it was important to practice, and we made a boo-boo. Maybe because I didn't box it. So this one is, this one's going to be x is less than or equal to negative 2, or x is greater than or equal to 8. That would be the answer. 2 more. 2 minus x is greater than or equal to 1, or, because it's greater than, 2 minus x is less than or equal to negative 1. Minus 2, negative x is greater than or equal to negative 1. Divide by negative 1. X is less than or equal to 1. Minus 2, negative x is less than or equal to negative 3. Divide by negative 1. We get x is greater than or equal to 3. Well, sorry, I don't want to. Oh no, oh gosh. Oh no, what's going on there? Cancel. What on earth happened there? That was weird. Don't save that. That was weird. That was really weird. Okay, so let's do our sketch. We have 0, 1, 3. Let's do highlights. We'll highlight that in green, highlight that in blue. Green, x is less than or equal to 1. That's a closed circle going that way. X is greater than or equal to 3. Closed circle going that way. That is an or, so that's okay. We would expect an intersection or a union, or wings as we say. Wings. And that would be our answer. Let's write that as a statement. X is less than or equal to 1, or x is greater than or equal to 3. Come on, give me a fun, crazy one. Oh, that looks pretty good. Give me a crazy one. I want a nice, hard one that gives you a bizarre answer. I will be honest, you know, these worksheets, the worksheets that we do are a little bit easier. Well, they're middle of the road, right? They're the minimum that you need. So I'm going to do in the Dolciani, the Houghton Mifflin book, the Algebra 1 structure method. On the homework, in the book, they have A, B, and C problems. So we're going to be doing problems from that. I'm going to be posting those. So that'll give you a really, really strong, really, you get to see all those 1% problems. So that'll come next year, maybe this summer. But I'm trying to get through this book for all the worksheets, and then I'll delve into the harder C problems. Maybe we just do C problems because these are typical A and B problems. So that's what you can look forward to. -2 minus x is less than or equal to 4. Less than is and. -2 minus x is greater than or equal to -4. Let's add 2. Add 2. Negative x is less than or equal to 6. Let's divide by -1. We get x is greater than or equal to -6. Add 2. Add 2. Negative x is greater than or equal to -2. Divide by 1. Divide by 1. X is less than or equal to 2. Let's sketch. Let's see what that looks like. That's going to be -6, 0, and 2. Nope, let's color, highlight, green, blue, green. X is greater than or equal to -6. That's closed circle. X is less than or equal to 2. Well, that wasn't very sophisticated. That looks just like every other problem. So as we see, we're not really getting too sophisticated we're just doing the plain Jane regular ones. So -6 is less than or equal to x, which is less than or equal to 2. And that's it. Don't know if you can hear that dog. I feel sorry for that dog. He's just barking in his house, and he's being neglected, and he's just saying, hey, I want to play. Have a great day. Good luck. Bye-bye.